Okay, so this is question number 1. Helen believes that the random variable C, representing cloud cover from large datasets, can be modelled by a discrete uniform distribution. Part A, write down the probable distribution for C. Okay, so part A. Now, for cloud cover from a large dataset, it's kind of like a circle, like a pie sort of thing going on. It splits up into 8 relevant sectors. Okay, like so. Now, if part of this is covered, then we've got maybe 4 out of 8 or whatever it might be for the cloud representing for that day. So for part A, if we had R, okay, as our variable, and we had a probability of X equaling R, okay, for 0, 1, 2, 3, 4, 5, 6, 8. Yeah, we only need 8 really. In fact, there only can be 8 because there only can be 8 in the set. So each of these is going to be 1 out of a possible 9, including 0. Okay. So that's part A. Part B, by the way, if I'm looking over, that's because I'm reading the questions. Okay. So using this model, find the probability that the cloud cover is less than 50%. So we need the probability of C, so random variable C, being less than 4. I'll call it as C, just so we know it is C. So the probability of that being equal to 4, well, that is just 1/9 plus 1/9 plus 1/9 plus 1/9. So it'll be 4/9. Okay. That is part B. Part C. So part C says comment on the suitability of Helen's model in the light of this information. Now, looking at what we have here, I've got written down that the 0.315 given in the question is less than the 0.4 recurring, which is what 4/9 is. So the model isn't suitable. Okay, so something along those lines will get you the marks. Part D is the discrete uniform distribution good enough, essentially here, or it's not, so Helen should not use a discrete uniform distribution. Reasoning, cloud cover varies dependent on location. Okay, so let's have a look at the mark scheme. For part A, setting that up will get you the marks there, or 2 marks. Part B, getting to 4/9 gives you 1 mark. Part C, it's getting 1 mark here, is it? I think it's 1 mark. So another mark for part C, getting that 0.315 is less than 0.4, so therefore the model isn't suitable. I'll give you a mark. And for part D, you're getting an explanation mark for saying, for another mark, that you shouldn't use a distribution, as cloud cover will depend on location, or anything along those lines, will get you all the marks. Okay? That's how we can get all the marks for question number 1. Okay, so this is question number 2. So we've got Tessa owns a small clothes shop in a seaside town. She records the weekly sales figures pounds W and the average weekly temperature T°C for 8 weeks during the summer. The product moment correlation coefficient for these data is the minus 0.915. Okay. Now, the first thing you need to look up for part A is in the tables. Now, in these tables for 2A, if you hop to these tables, you will find, if you go to it for Edexcel for the board that we're looking at, you will get the figure 0.6215. I've just had to look that up myself in the tables. Okay, to do this question. So for part A, we need to state your hypothesis clearly and using a 5% level of significance, test whether the correlation between sales figures and average weekly temperature is negative. Okay, so the first thing we need to do is we need to let P be the product or population? Population correlation, we'll call it. So that's the first thing we do. Then we need to state our null hypothesis, which is H0 and H1, the alternative. We need to state both of those. Well, that will say that the probability is 0. Then the alternative will say it's less than 0, saying it's negative. Okay? So the minus 0.915, well, that's less than the negative 0.6215 that we had from the tables. So the result is significant. So reject H0. So reject the null hypothesis, and our final sentence will say there is evidence to suggest that the correlation between sales and temperature is negative. Okay, that's part A. Part B. Suggest a possible reason for the correlation. Well, when temperatures rise, more people are likely to visit. The seaside. Okay, something along those lines. Part C says state giving a reason whether or not the correlation coefficient is consistent with Tesh's suggestion for part C. Okay, well, this minus 0.915 is a strong negative correlation. So a linear regression model is suitable. Okay, something along those lines. For part D, T is the temperature variable here. The temporary variable, or the exploratory, should I say? Get the right one. Exploratory variable. As this affects sales numbers. Okay. Part E. Well, an interpretation of the gradient of the regression equation where W is equal to the 10.755 minus 1.171t, is it? Something like that. Yeah. So for every 1 degree centigrade, the sales decrease by 171. Okay. So let's have a look at the mark scheme. Part A, we're getting a method mark for finding the value 0.6215 in the table. Another mark for stating the hypotheses clearly. Another mark saying that the result is significant. And our final mark for that one saying that there is evidence to suggest that the correlation between is negative. So our final conclusion there. For part B, so as temperatures rise, more people visit the beach than the town, something along those lines. Got that there, didn't we? For part C, the minus 0.915 is a strong negative correlation, so a linear regression model is suitable. Got that pretty much on the money, didn't we? For part D, temperature is the explorative variable, as this will affect the sales figures or sales numbers, yeah, got that. And for part E, for every 1 degree centigrade, the sales will decrease by £171. Okay, so we got that. Okay, and that's how we can get all the marks for question number 2. Okay, so this is question number 3. So in an experiment, a group of children each repeatedly throw a dart at a target. For each child, the random variable h represents the number of times the dart hit the target in the first 10 throws. So Petter has a model where h is binomially distributed with 10 and 0.1, so I've got that on the board for myself. For part A, state 2 assumptions Petter needs to make to use her model. The probability is constant, maybe? Another one could be that the throws are independent of each other. Okay, we've got that as well. For part B, it says, using Petter's model, find the probability of h greater than 4. Well, the probability of h being greater than or equal to 4, well, I'm going to have to use the 1 minus the probability of h being less than or equal to 3. Okay, which is equal to 1 minus. This is where you need your calculator. So obviously I got my calculator class whiz that you should be using for A level. So if I go to menu and I go to number 7 for distributions, I go to binomial CD, I go to variable, and I type in following. 10, my probability is 0.1, and my n will be 3. And I get 0.987204816, I think, something like that. Yeah, hopefully you get that. So to do that, I can make that calculation. I get the 0.01 2795 and that will be 0.0128 to the required 40, something like that. Okay. For part C, using Petter's assumptions about this experiment, find the probability of f being equal to 5. Well, surely you can just find that as 0.9 to the 4, because remember, if it's not being hit every time, well, that's 0.1 off the 1 for a whole probability, which is 0.9. You're throwing it 4 times, so 4 times you're going to get it right. So it's 0.9 times 0.9 times 0.9 or 0.9 to the 4, using your indices laws. And I'm going to be multiplying that by a 1, which is going to hit the target first, which is the 0.1. Okay, calculate that on the calculator. So I go 0 to menu number 1, 0.9 to the 4, multiplied by 0.1, and I'm getting 0.06561. Okay, that's part C. Part D. Part D, the probability of f equaling n is equal to, just so I've got it on the board for myself, 0.01 plus n minus 1 times alpha. Okay. Well, the way this is going to work, you don't have to draw the table necessarily, but it is helpful, I think. So if you draw your tables all the way up to the value of 10, well, this is going to be 0.01 plus how many alphas? Well, that's going to be 9 alpha. Okay, so you've got 9 alpha. You've got the 0.01 here. You've got the 0.01 plus alpha and the 0.01 plus the 2 alpha, and so on and so forth. Now, solving that, all of these have to be equal to 1, so that will say that the 0.1, if you add them all, the 0.1s up, you get 0.1, plus how many alphas? Well, that will be 45 alpha, yeah, which is equal to 1, which implies that alpha will be the 1 over 50. So the 0.02, okay? And that is the value of alpha. Okay. Part E, the probability of f equaling 5. Well, that is not that hard to do, is it? It's 0.01 plus 4 lots of 0.02, which is 0.09. Yeah, 0.08 plus 0.01 is 0.09. Part F. Explain how Pettit and Thomas models differ in describing the probability that a dart hits the target in the experiment. So I'll just explain this one. I might write it down, just write down what I say. So the Pettit's model assumes the probability remains constant, while Thomas's model has the probability increasing as more throws are taken. So look at the mark scheme. Let's get the mark scheme. For question number 3. So getting a mark, getting 2 marks for the 2 assumptions, so they're independent and the probability is constant. For part B, we are getting just the 1 mark for the final answer of the 0.0128, or anything that rounds to they give it anything that rounds to 0.013. Get you the marks. Part C, the 0.06561 will get you the marks there. We'll get you the 1 mark, and the 2nd mark will come from the first equation that you've established, so 2 marks there. For part D, you're going to get, how many marks is this? This is 4 marks. So you're going to be getting a method mark for getting the equation, and getting down to this will get you the 2nd mark. The 3rd mark will get into alpha is 1 over 50, and the final mark is converting that to a decimal to get the 0.02. For part E, I'm not done part F, but F will get you the mark. For part E, just subbing in f of 5 and getting the 0.09, 0.01 plus 4 alpha. So dealing with that will get you the mark. And part F, just reading part F, probability remains constant while the probability is increasing as more throws taken for Thomas's model, so they are different. Okay, and that will get you all of the marks for question number 3. Okay, this is question number 4. So, question 4 says Charlie is studying the time it takes members of his company to travel to the office. He stands by the door to the office from 8:40 to 8:50 one morning and ask workers as they arrive how long their journey was. Okay? Part A. State the sampling method Charlie used. Well, this type of sampling is opportunity sampling. Now, opportunity sampling usually is, if he has the opportunity to do so, he will choose the opportunity to do it. So it is opportunity sampling here. Part B, state and briefly describe an alternative method of non-random sampling Charlie could have used to obtain a sample of 40 workers. So a quota sample could be pretty good, I suppose. So 20 male and 20 female. That could work. Okay, part C. Look at part C. Taruni, is it? I don't know, I can't read his name properly, but whatever. Decided to ask every member of the company the time X minutes it takes them to travel to the office. Part C. State the data selection process Tarani used. Well, he used a census. Yeah? Should know where that comes from. Part D. Okay, write down the interquartile range for these data from the box plot. Okay, so we need the lower quartile. Now, looking at the diagram, I've got a picture of the diagram on my sheets here. I'm guessing that it's about 26. I can't say for definite, but there will be a range as well, don't forget. The upper quartile, looking at that, it's about 58. It's really a rough estimate, that one. So the interquartile range from those data is the 58. Take away that 26, and I get myself 32. Yeah. Part E. Calculate the mean and the standard deviation for these data. Okay, so X bar the mean. Well, X bar the mean is, let's get the calculator. Let's get the calculator out, we'll need it in a second. Is the sum of n all over n, or the sum of x all over n, is the way I like to do it. Now the sum of x on the table is the 4133, and I'm dividing that by 95. Now the 4133 divided by 95 is 43.5 to 1 dp in minutes. Okay, so that's the mean. Now the standard deviation formula is given to you in the formula booklet. Now I've got it written down here from the formula booklet, just to remind myself, is the sum of x squared over n, take away the mean squared. It's that formula that you want for that one. Now summing into that, let's just do that. And I'm getting 15.38512331. Yeah? So let's write that down. 15.38514231. Now, does it want it to a specific range? No, it doesn't, so we'll give it to at least 1 dp, which is 15.4 minutes to the 1 dp. Part F. Part F says, state giving the reading whether you would recommend using the mean and standard deviation or the mean and quartile range to describe this data. So the mean and the standard deviation are shared using outliers. So median and IQR. Part G. Explain which two values surrounding must have changed and whether each of these values have increased or decreased. Now, from that box plot then, so I'm going to draw that box plot out from what I have written down here. The outliers. Point 1, point 2, roughly about there. Okay. Now this one will move down, and so will this. Yeah. Realistically. So if those are both going to move down, both the median and the quartile will decrease, as the two values in the upper whisker will move below the median. And that's the final conclusion today. I've told you that, so I'm not like that. Okay? So, on the mark scheme, I wrote it down on here as well, in my notes. So you get just the 1 mark for part A for opportunity sampling, we got that, didn't we? Part B says a quota sample should be used and decide on a quota of 20 males and 20 females. Yeah, basically got that, didn't we? Part C, 1 mark sensor. Part B, right down the quartile range, got 32. Part E, summing in values, would have got your marks. Part A. Part B, determining the following first sample deviation, summing in, point 4 will get you a mark. Part F, here we had 2 marks for the reason plus stating that the mean and IQR are most appropriate. On part G, we've got 3 marks, we've got 1 mark for stating that they will both decrease, the meanings, and showing that they will decrease on the and that's how we can get all marks for question number 4. Okay, this question is fine, so the lifetime L hours in the factory has a normal distribution of mean 80. Standard deviation 4. Okay, now let's normal distribution stop working when any one battery reaches the end of its lifetime. Find the probability that a random selected battery will last for longer than 16 hours. Okay, well, probability that the lifetime will be greater will be, well, let's put that straight into a calculator. So, for this question, you need to go to menu, go to number 7, you need to go to normal CD. Yeah. I'll put in our lower one. So standard deviation. And I'm guessing 6, the probability that her calculator will not stop working for Alice's remaining exams. Okay, so we need to use a little bit of notation. It's not too big. The probability that it's greater than 20, sorry. Given that probability of L being greater than 16. what we want. So we've got the probability of being greater than 20 and the probability that L is positive and greater than 16. I want to divide that by the whole probability of L being greater than 16. A lot of words here, I know, but it's a hell of a lot easier, which is the probability of L being greater than 20 over the probability that L is greater than 16, which is, let's jump to our calculator again. You need to go to menu, you need to go to number 7, you need to go to number 2 again. There we go. So our lower value, so the lowest one it can possibly be is 16, up a value of 20, and I'm getting the solution for the probability of that being over 20. I'm getting the 0.308 537 Yeah, I get that. I want to divide that by the 0.69146246 from part A. Okay, which is 0.44621 0106. Do you get that? Please check that you got that. Don't forget this question is not finished yet because I've got 4 batteries. And I want to do that to the power of 4 because this question isn't finished yet. So the 0. If I go to number 1 and do the 0.44621 01016. Okay. And I've put the answer to the power of 4. I'm getting 0.039642187726. Okay, which is 0.039624 dp. Yeah. Part C. Part C says show that the probability that her calculator will not start working for the remainder of her exams is 0.19923 Okay, well, this is 0.4462 squared. And I'll multiply that by the probability of it being greater than or equal to 4 all squared. Okay. Make sure I put my extra brackets where required. So we need to multiply that by the probability of it being greater than 4, which is the 0.9997. It just keeps going on and on. 67379. Okay. That should be all squared as well. Okay. Which is the 0.199010835, which is equal to 0.199 to the 3s as required. Okay. Part D. And then we've got stating your hypotheses clearly and using the 5% level of significance test Alice's belief. Okay, so the first thing is you want to let mu be the population of mean lifetime, we'll say, of a battery. Okay. So the null hypothesis on the alternative, well, the null would say that mu would be positive, yeah? Would it be saying it'd be equal to it, won't it? The alternative would say it'd be positive and also greater than the 18. So the first thing you want to do is assume that this H0 is true. That's the first thing we do. So that L bar is normally distributed with the 18 and the 4 squared out of the possible 20. Okay? So the probability that L bar, yeah, is greater than the 19.2. That should be 20, by the way. You wondering? Okay. Well, that is. Back to my calculator once again. I need to go to menu number 7 once again, and I need to go to normal. So the x value is the 18. The standard deviation is 4 squared divided by 20, and we've got the 19.2. And I'm getting an answer of 0.089 8562. Leave that for now, not give the full calculator display. Well, that is greater than 0.05. Something going on there? So, the result is not significant, so fail to reject H0. Unfortunately, we failed to reject H0, so there is insufficient evidence to suggest. What have I written here? Insufficient evidence to suggest that the mean lifetime is greater than 18 hours. Okay. So look at the mark scheme. Okay, so look at the mark scheme. Flip it over. Question 5. Okay, we're getting a mark straight away for setting up this normal distribution. The next mark, we're going to get the 0.6915. Immediately get that mark. Part B, we're going to get this mark here. Also, the next mark is followed by this. So that and that will get you the second mark. Followed by that for the third mark. Fourth mark is coming from the 0.44.62. Getting that. And the final mark is getting down to that 0.0396 for DP, or anything that rounds to 0.040 would get you the marks as well. Okay. For part C, just getting that will get you a mark. So getting the equation, making sure you find that, and getting that will get you the third mark, get you the answer. For part D, there was 5 marks available here for stating your hypotheses, H1 and H0, mark a piece there. You get a mark for setting that, and you're also getting a mark to get down to this stage, and you're getting your final 5th mark for rejecting H0, and there is evidence to suggest, there is not enough evidence to suggest that the mean lifetime of batteries is greater than 18 hours there, but that would be just as good from what I wrote. That would be just as good. Okay, so that is all the marks for question number 5, and we're now into the mechanics section. And the mechanics section looks pretty tricky, and they are not easy, these mechanics questions. So we'll give them a go in the next question. So mechanics up next.